Hello and welcome to the lecture about Prim's algorithm. Prim's algorithm is a greedy algorithm that finds minimum spanning tree where the total weight of all edges in the tree is minimized. There are conditions corresponding to original graph. The first one is that the graph must be connected, undirected, and weighted. Additionally, parallel edges and self loops are not allowed. Also, there are some conditions related to the minimum spanning tree. There must be no cycle in the minimum spanning tree. For further information about cycles, you can refer to the video above. And the minimum spanning tree must contain all vertices. So let's dive into an example. Suppose we're given this graph. Step 1 is to initialize the minimum spanning tree with an arbitrary vertex. I choose node E randomly. Step 2 is to add next vertex with the minimum possible edge connected to the node E. There are 3 nodes that they are connected to the node E with 3 edges. However, the least weight value is the edge between C and E. In the next step, find the minimum edge regarding all edges connected to E and C. There are 3 possible nodes and 4 edges. Minimum possible edge is between E and D with a weight value of 3. Repeat previous steps but be careful to not form a cycle in each step. You can suppose that we treat E, C, and D as a single node and we must add the minimum edge that is remaining. Now there are 3 possible edges. As you probably noticed, adding edge between C and D forms a cycle and is not allowed. Choose edge between E and A that has less weight value. Finally, last vertex will be added by minimum possible edge. Last minimum weight value is between A and B with a value of 2. Adding more edges will form a cycle, so stop here and the minimum spanning tree is completed. Maybe you have noticed that a special case can happen when we have more than one edge with the same weight value. Suppose that the weight value between D and C is 3, just as the same as between E and D. Pick the edge between ED or DC randomly and move on until there is no cycle. I hope you enjoyed the learning and thanks for watching this video.